that again. It's a Redskin.
Semicircle gamma has diameter AB of length 14. Circle omega lies tangent to AB at the point P and intersect gamma at point Q and R. Okay, so let's see. Semicircle diameter AB. Length 14. Circle omega tangent to AB at point P and intersect gamma points Q and R. Okay, so it will be something like this. It is A, it is B, it is Q, it is R, right?
Yeah.
QPR is this one. QPR is 60. And QR, it says also the length of QR. And then we should solve the problem. Like it's over here. Minimize it. So this one is 60. And we should calculate area of PQR. Okay. So the diameter of this circle is 14. Is a 7, right? The radius, right?
The radius is 7.
Okay, so it is 60. We want to find, and this one we know is 3 root 3. So suppose, for example, let's consider this one R1, this one R2. We can easily say R2 is what I told you the formula before. Calculate R2.
Is R2 the small radius?
Yes, radius of this circle.
Yeah, okay, I'm just drawing the diagram. So the little radius is 3.
Radius is 3. Okay, let's check. Do you remember the formula was what? R is what over what?
I don't know what kind of like thing
I
this is.
told you A over 2 sine A. Do you remember these?
I know this, but I know this.
So
but this
3
is
root 3.
circles.
A was the sine and 2 sine this angle. 2 sine 6. Okay? So 3 root 3 over root 3, which is 3. Okay? Understood?
Yeah.
Okay, so R2 is 3. Now it's good because we found the radius of these two circles. And both of these two, usually how I told you when we have two circles that intersect each other, draw this line always. I think I told you, right?
Yeah.
And this line, the name of this line is what?
The radical axis.
Exactly, radical axis. And this line has lots of properties. You can relate the angles. And one important thing is that O1, O2, what's the relationship between O1, O2 and this line?
It's a perpendicular bisector.
Exactly, perpendicular bisector. So if we consider this center and this center, because now we have radius, and these two centers lies on perpendicular bisector of this, and because it is tangent, if you consider center of this O2, can you tell me O2 lies on what?
O2 lies on what?
So here, let me copy it. Okay.
So perpendicular to.
So if we raise these things, we know that if we connect O1 and O2, perpendicular bisector O2 lies on it. And if we consider perpendicular to this, we reach O2. O2 is the intersection of these 2 points, right?
Yeah.
Okay, and now we know lots of things. O2P is what?
O2P is 3.
Exactly, O2P is 3. For example, here, MR is what?
MR is MR. Oh, MR is that point. Okay, yeah. MR is 3 root 3 over 2.
Exactly. So O1M, calculate. We want to calculate all lengths that we can. O1R is what?
O1R. Wait 1 second. Okay, O1R is, yeah, Pythagorean theorem. So
No. O1R. You don't need to apply any theory.
that O1, 7.
7. Let's calculate length as much as we can. O1M is what?
O1M is 7 squared minus MR squared. Pythagorean theorem.
927 over 4, right?
Yeah.
So it will be what?
But I can't hear you if you're saying something. So it's 13 over 2.
13 over 2. 4 times 49 is what?
196
minus 27 over 4. 196 minus 27 is 9. 169 over 4, which is 13 over 2, right?
Yeah.
Okay, so we found O1M. O1, O2 on. O1, O2 is what? Can we calculate O1, O2?
O1, O2.
We can calculate O1, O2. Try.
Yeah. It's 5.
Okay, let's check. First, we should calculate O2M, right?
Yeah.
For O2M, it is the square root of O2R squared, which is 3 squared, which is 9, minus 9 times 327 over 4, right? So
Yeah.
36 minus 20 is 3 over 2, O2M. So O1, O2. O1M is what? 13 over 2 minus 3 over 2, which is 10 over 2, 5, right?
Yeah.
Okay, so we found O1, O2, O2M, O2P, all these things. Now try to see area of QPR is what here, okay?
Okay.
Try.
Okay, I solved it with coordinates. I don't probably a better way to solve it.
And you've reached what?
99 root 3 over 20 is 122.
This one?
Yeah.
Okay, can you explain?
I just set P to the origin. I set O1 to 40. And then
Yes.
O2 to 03.
Okay, so let me
So I know.
write. O1P is 0, right?
Yep.
Because O1P, have you calculated O1P? No, but we can calculate. It is O1, O2 squared 25 minus O2P squared 3, it is 4.
It's a 3,
So
4,
because
5,
this length is 4, O1 is 40. Then what? O2 you said is, yes, 0.3. What else?
3. So the slope of O1M is negative 3 over 4.
Let me write. The slope is negative 3 over 4. Yes. Then what?
And then the slope of QR is 4 over 3.
Yes.
So now I just want to find what M is. So I know that O1M is 13 over 2.
Yes.
So now I just do 3 over 4 and 4 over 5. So I find that M is negative 12 over 10, 39 over 10.
Negative 12 over 10, 39 over
10.
Okay.
That's
Yeah,
M.
we can write the equation of this line because we have O1 and these. And you can write also We know this one is 13, one equation, and also this slope is 4 over 2. Yes. Then what?
So now I have a point and a slope of QR. So I write y equals 4 over 3.
And you have also this length, so you can find Q and R. Then you use shoelace theorem, right?
No, I didn't use shoelace theorem. I just found the distance from QR to P, and then I
use this. Okay. Because when you find equation of QR, you can use the distance on this one, right?
Yeah.
And when you find M, you have a slope, you can write the equation of this line, and you can only find the distance, right?
Yeah.
Okay, good job. And look, we can also do exactly the same thing because we know the distance of, we know this length QR, and because we want to find area, so we have to find this distance, right?
Mm-hmm.
P to this. So for example, PM, we want to find PM. Agreed?
Yeah.
But because we have O to M, so we can draw perpendicular because we have these parts, right? We can call it L. So we want to find Pn is what? Pn is equal to PL plus NL. NL is what?
MO2.
NL is MO2. MO2 is what?
3 over 2.
Yes, MO2 here we found is 3 over 2. So PL plus 3 over 2. So if you find PL, the problem will be solved, right?
Yeah.
So this one is 90, 90, 90, 90. So if this angle is alpha, this angle is what?
Which angle?
This angle. If this one is alpha, this one is what?
90 minus alpha.
So this angle is what?
Alpha.
Exactly. So do you agree these two triangles are similar?
Yeah.
So we can find PL. PL corresponds to what?
O2P.
Alpha O2P, and we know the radius. So here we know what O2L is better, or LP. LP we said O2P is good. O2P corresponds to what?
O1, O2.
Exactly. So we can find PL. O2P is what?
3.
And here O2P again 3. O1, O2 is what?
5.
So PL is what?
9 over 5.
So Pn is what?
9 over 5 plus 3 over 2 is 33 over 10.
Yeah, so the area is 33 over 10 times half of the base, right?
Times 3 with 3 over 2.
3 with 3 over 2. It is the area. It's 99.3 over 20, so 23, 1, 2. Okay.